Okay, good morning everyone. My name is Nikhil Kumar, faculty of IT department in Ajay Garg Engineering College. So today we have the subject that is the big data and the code is the BCS061 and we have the topic Hadoop ecosystem. It is a lecture series of big data and already we have covered 4 lectures that cover the big data, the semantic introductory part and the types of big data and the uses, and we also discussed some concept regarding the tools where the big data stored elements, the data is already stored, how it will be fetched, and all the process mechanism will be discussed in earlier lectures. So today our main concern should be on the Hadoop ecosystems. That is the Hadoop ecosystem. In the last lectures, we also discussed the NoSQL. That is the, till now we have the concept that is the RDBMS, and due to some limitations, we switch to the NoSQL, and after that we move to the new SQL. So surroundingly, there are some limitations, and after upgradations, the existing tools and the possibilities, whatever we want to be update, we update simultaneously. So it is a time consuming process, and on time basis we have update its qualities. RDBMS is based on the static data structure. That means when the data are in the similar format, so that we can say that it will be the static way. So we use the RDBMS concept, that is the relational database management system. And due to these limitations, we move to the NoSQL, where all different type of files are merged and can processed after a simultaneously requirement. So these are the terms that we discussed in the last lectures. So we are on the point that is a SQL versus NoSQL versus the new SQL. So in this slide, we will discuss all the points that are the part of the that simultaneously we will discuss that what is the basic difference and what are the agenda for the to discuss the SQL, NoSQL and new SQL. So these on these basic properties we will discuss all the terms. The ACID property, that is the atomicity, consistency, isolation and the durability, comes under the it will proceed in the SQL, okay, because it is the RDBMS concept, relational database management system. In case of the NoSQL, this property is missing, and new SQL we introduce the ACID property, so that when the data is processed, we achieve the ACID property all the time. Atomicity, consistency, isolation and durability will be achieved. The next one is the OLTP and OLAP. In SQL case, it is present. In NoSQL, it is not present, and new SQL we achieve the property of OLTP and OLAP. Schema, rigidity, adherence to the data models. We know that whenever we in the existing database, if we have provided, we have the static schema, whatever we have, and the new data values want to be add on the current existing database. So if it is only possible in the concept of the RDBMS or SQL case, if it will match the existing database. Let's suppose we have the some predefined schema, that is the serial number, name, roll number, and there are some already existing values, and let's suppose we want to add on some extra set of values. So if the existing the values which we want to add on in the existing database have the same schema, so we can comes to the SQL theory. Otherwise, some values will be missed, or some data on the basis of some values we add on the not applicable value. That means we add extra values that is not requirement and that are not mentioned on the given database value. So what's happening here? There are the two possibilities that some value can be missed, and there is only a one choice is can also be there, that we add on some extra space. That means we add some extra values that just like the not applicable, zero and null values to acquire the whatever the existing schema is provided. So that are the concept of SQL. But in case of the NoSQL, no such type of property requirement, and maybe case will be done in the new SQL. In case of the data format flexibility, no data, that means there is no flexibility provided in this case. Yes, provided, and this is the maybe case. Scalability done on the vertical scaling. In the last lectures, we already discussed that what the means of vertical. When we add on some values, it will be add on the vertical side. So it is called the vertical scaling. But in case of NoSQL, it is a horizontal scaling. That means all the similar or dissimilar type of data will be add on the parallel side. That is a horizontal side. So it is a horizontal scaling, and scale out is the concept. That means parallel and the horizontal and vertical scaling is done on the both sides. Distributed computing is done on the SQL. Yes and yes. Community support for the case of SQL, it is huge amount, growing and slowly growing. That means because RDBMS is the predefined structure formation, and most of the time we use this one SQL. So these are the growing concept. So slowly it is growing. In case of the Hadoop formations, what we have the Apache open source software framework. Apache introduced the concept of the Hadoop, and it is provided by the Apache gives the license to the Hadoop for its proper functioning. It is inspired, Hadoop is inspired by the two possibilities. That one is the Google MapReduce, and second one is the Google file system. When these are the existing tools for the mapper and reducer functions, and we add on and inspired from the this property and add on in the Hadoop structure. After that, some theories update and upgrade. So after that, it comes to the Hadoop distributed file system, that is known as the HDFS, and the MapReduce. We know very well that MapReduce contains the two operations. First one is the mapper, and second one is the reducer. It is a very basic concept. Mapper provides the mapping functions so that where the existing file is stored, so we directly can move to that positions. And reducer provide the systematic way. Let's suppose any existing file is not updated at a number of time series, and due to some limitations and due to some frequently, and there the concept of the when its replica is generated, so that it required that its existing applications, existing files should be repeat again and again. So what we will do, we will reduce the repetitions value, so that when the value is not update, so we take its one times, not update its value multiple times. What will be the feature, what will be the property, and why we use such thing? Because it will eliminate the memory wastage. We know very well that memory is a very basic concept for all the big data concept, because if without the repetitions value, that means the value is not updated and we use multiple time to update it. So most probably it is the chance that it will take some space in the memory bar. So we reduce this one. So that is known as a mapper and reducer. Two operations are done simultaneously, and it is done by the concept of MapReduce. What are the key advantages of Hadoop structures? These are the key advantage. First one is the stores data in its native format. Whatever it is required, it is the possibility and what are the its native locations and the format. So similar way it will be stored in the database without update, without upgrade and change its format value. It is scalable in nature. That means if any value is existing and we want to update its value multiple times simultaneously, surroundingly, frequently, so it will be done by the scalable. That means its value can also be updated and the number of entries regarding that database can also be add on, update. So that is the concept of the scalable, because Hadoop contains the large volume of data. It is cost effective. We already discussed that there is no requirement of external hardware. It only processed just like the Linux command. We will use some commands throughout all the Hadoop ecosystem. We will discuss later. That contains the number of different tools for data storage, process and retrieval of information. So that provides the cost effective mechanism. Resilient of failure in case of data is missing or failure and not responding from the any type of data suits values, the different nodes. So what we have the possibility to do, we have the number of replicas existing. So let's suppose these are the number of nodes that are communicating and these values update its value. But let's suppose what's happened, the communication from this node to this one is cancelled out. Okay, when this node to this node is cancelled out, so how it will be update its value, that such node have update its value, it will not be reflect from this one because the communication media and there is some chance that such communication is disturbed, because due to the limitations and the concept of the Hadoop ecosystems concept, its original values will generate the replica and will store in some other nodes. So what's happened when such communication is disturbed? So this node will communicate to this one and proceed for further. So what's happened? The communication will not be stopped. Simultaneously, all the activity will be done. So it provides the flexibility in the. It also provides the resilient of the failure. In case of failure, what we will do, we discuss now. It is the flexibility for the communication, and we will choose the better and optimal options for the communication. Let's suppose the original file is not responding. So what we will do, we will check that what is the optimal node and the replica node through which the communication is done. So it is provide the flexibility. All the things have been done in the fast way. So it provides the fast process of the Hadoop ecosystem. What are the versions of Hadoop ecosystem? We have the two versions, version 1 and version 2. In version 1, we have the MapReduce and HDFS. In MapReduce contains the cluster resource manager and data processing. All of their things have been done in a similar way, but due to some limitations we have arranged here. In the HDFS provide the redundant and reliable storage. Due to some challenges we face in the Hadoop 1.0 version, so we come to the next version, that is the Hadoop 2.0, which also provide the MapReduce with the data processing concept. It is the upgraded version of the existing tools, and some other tools are processed also, just like the Hive, HBase and the ZooKeepers. We will discuss later. In Yarn, that is known to be the yet another resource negotiator, will provide some mechanism for the managing purpose of the resource, whatever the tools are we using in the combined form of Hadoop ecosystem. So that provides the resource management, and that is the HDFS. So this is the whatever we are discussing here. This is the Hadoop ecosystems, different tools, just like the Sqoop, that is the relational database data collector. Sqoop is just the form of the SQL plus Hadoop formations. Sqoop is just like the SQL plus Hadoop formations. Mahout provide the machine learning concept. Let's suppose there is the first thing is all the things have been done by manually, and the second one is it will be done by the autonomous, and the third one is the autonomous will be done, and the ecosystem is just built up with the AI tools and machine learning advantage, so that when the communication have been done, so it provide a tools where communications and all the things that will be upgraded and the machine will be learned through the machine learning, and with the database existing tools, the process and retrieval will be done by the machine learning concept. When the concept of machine learning have been done in the Hadoop ecosystem, that is done by the Mahout concept. Tools Pig provide the data flow. Data flow means from where to where, the position from the sender to receiver, how the data will be smoothly fetched, retrieved, and where its replicas have been generated, the number of times where the data is accessible, and everything about the data transfer possibility have been done in the Pig structure formation. The next one is the R. R is a programming language that provides the statics values of the data representation in this concept of Hadoop ecosystem. Hive is the data warehouse which connect with the just like the how the data will be stored in the existing and predefined and the predefined database, and when the different type of format will be available, how it will be managed. So it is the responsibility of the Hive data structure. Oozie is just like the workflow of mechanism for data upgradations, update, delete, and new cells are generated. So it will be done by the Oozie system. Flume and Sqoop provide the log data collector. Let's suppose the existing tools want to update its value, so and multiple time it will be updated. So on the basis of the time frame, what value will update at which time period, it will be done and supported by the Flume and Sqoop. Distributed processing have been done by the MapReduce. HBase provide the table store distributed network of data storage. The HBase provide the Hadoop structured formations of database. Whatever we discuss these tools, and it will be managed by the ZooKeeper. The major responsibility of the ZooKeeper is the coordination between all the tools that connect with the Hadoop ecosystem. These combinedly form the discussion of these tools are considered in the Hadoop ecosystem, and in the Hadoop ecosystem, all the tools are connected through different responsibility and to different tasks, and it will be controlled and managed by the ZooKeeper tools. And it is the HDFS, Hadoop distributed file system, just like the NTFS or the Windows operating system, how the file is managed. So HDFS provide the Hadoop distributed. It is just like the file system of Hadoop ecosystem. So completely it is the Hadoop ecosystem, and all the tools and the unit 4 and 5 are based on the particularly on these tools. Hadoop ecosystem connect with the component that have help with the data ingestion. Data ingestion means how the data value will be input to the existing database value, and it will be done by the two tools, Sqoop and the Flume. Component that help with the data processing. So processing will be done on the basis of these tools, MapReduce and Spark. Component that help with the data analysis. So for the data analysis, we use the Pig, Hive, and Impala tools. So sometimes there is a number of questions can be asked in the university examinations, that what are the difference between HBase and Hadoop, Hive, ZooKeeper, and whatever the existing SQL command and the Hive command and the ZooKeeper command, how it will be different from the version 1 first to version 2, Hadoop version 1 2, what is the difference between Hadoop version 1 and 2, and so on. Things will be done, can be asked in the university examinations. So HDFS is the file system where as HBase is a Hadoop database, whatever we are discussing, it is like the NTFS and the MySQL that are mostly discussed in the Windows operating systems. HDFS for me is the write once and read multiple times or many times. HDFS is based on it is supposed to be inspired by the GFS, Google File System, and the Google File Maintenance, that is based on the Google Big Tables, process table. The other tools are Sqoop and Flume. Sqoop stands for the SQL to Hadoop structure formation. It can provide the data from the external system to the HDFS system, and Flume provide the log aggregator. So whatever we are discussing till now, it is the extension and explainable way to discuss. So I think that we have already discussed these tools in all the manners. You can go through these slides. These will reflect that whatever we discuss. These are the MapReduce, Spark, Pig, Hive, Impala. So thank you class for attend these lectures. It is very important, and I suggest to you that kindly go through all the recent topics regarding the big data. It will be very helpful for the examinations and for your remarkable achievement for the understanding. So thank you.